Section 4.1, moment of a force. The objective for this video is to understand the concept of a moment. Shown here is a system consisting of the computer monitor carrier and the monitor itself. I've tightened the screws such that the angle between the linkages of the carrier remain the same. I can rotate the system by pulling on it with some force, and it will eventually cause the system to have a tendency to rotate in the counterclockwise direction about the clamped end. The magnitude of this tendency to rotate is called torque. However, in statics, we'll call it moment. Here you see a pipe wrench. Let's say I apply a force F in that direction. And what I'm trying to do is rotate this nut about this point O. Due to this force, the pipe wrench will actually rotate in a counterclockwise direction. So the tendency of an object, in this case the nut, to rotate about this point is defined as the moment. To determine the moment of this force about point O, what we first have to do is draw a line of action of that force and find the perpendicular distance from the point of rotation to this line. So in this case, it'll be like that. So this distance right here, we call this the moment arm, or we can just call it D perpendicular. So the moment about point O due to this force is defined by the magnitude multiplied by this moment arm, D perpendicular. Presented like this is actually a scalar value. However, the moment is actually a vector, and so a moment is a vector. That means that it has magnitude, which is this. It also has direction. The direction is determined by using the right-hand rule. Let's review the right-hand rule now. So the right-hand rule means you have to use your right hand to determine the direction of your moment vector. Suppose we have the x-axis downward, y-axis to the right, and z-axis is coming up at you out of the page, and we'll label that point as point O. And let's say this is some kind of structure, and it's pinned at point O. And let's say I apply a force F in this direction. To determine the moment of this force about point O, the right-hand rule is applied like this. You determine the moment arm, so this is my moment arm. You'll direct your fingers along the moment arm, and you'll sweep your fingers towards the direction of that force. That causes your thumb to point up in the positive z direction. Therefore, the moment about point O due to this force F is equal to the positive of F times that D perpendicular, and it's in this direction. Now let's say we have another situation where there's a force, a different force being applied, let's say in this direction. So we'll call that force 2. So the moment due to force 2 about point O is given by the following. And let's label this as 1. just to make clear. So the moment about point O due to this force 2 is given by the following. So moment about point O due to force 2 is equal to the magnitude of this force multiplied by the moment arm, which would be the perpendicular distance from point O to anywhere along this line of action of F2. So that would be right there. So this is my moment arm for force 2. Therefore, that would be D perpendicular 2. The direction of this moment vector is actually determined by directing your fingers along D perpendicular. So it would be like this, and it would have to sweep in this direction, causing your thumb to go downwards into the paper. So again, along the direction of the moment arm, sweeping in the direction of the force will cause your finger to point into the paper. That is actually our negative z-axis, so therefore I would have to put a negative sign there. 4.1, let's do several problems to demonstrate how to calculate the magnitude of a moment. So let's say I have a wall and there's some kind of bar, like an angled bar that looks like that, and it goes down. And the dimension is 2 meters here. Let's say that's 2 meters. And I apply a force of 50 newtons. And I also know that this is, let's say, 1 meter. What I would like to find is the moment about point O due to this force 1. So let's calculate that. So the solution will be as follows. I know that in a scalar form, the moment about point 1 would equal to the perpendicular distance times the force F1. So that would mean I can draw this line of action of force F1, and all I have to do is determine the perpendicular distance from the point of rotation to anywhere along that line. So this would be D perpendicular. So in this case, that would mean it's 50 newtons times 1 meter. That would produce a 50 Newton meter moment about point O. And let's see here. It actually would cause it to rotate clockwise. Therefore, that would be a negative value. Right, so we can either write it as a negative 50 Newton meter using the coordinate system x, y, or I can also express it as moment about O due to force 1 is actually 50 Newton meter, and I can just indicate the rotation. Let's do another problem. Let's say I have a wall, and I have another bar, and it's shaped kind of weird. It's actually like that. And this dimension right here is, let's say, 3 feet. And let's say a force of, let's say, 60 pounds is being applied right there. And they also let us know that this is at an angle of 45 degrees. Right, so that's 45 degrees. And they also let us know that this distance right here is 1 feet. And what's required is they'd like to know what the moment is about point O due to this force F1. So the solution then would be as follows. I need to draw the line of action of force F1, and I now need to determine the perpendicular distance. That would be this distance right here. This would be D perpendicular. That would be equivalent to finding this distance right here. Right, so approximately from there to there. So that would be the sine of 45 is the opposite, which is my D perpendicular, over hypotenuse, which is 1 feet. Therefore, D perpendicular should be 1 times sine of 45 feet. So to calculate the moment about point O due to this force F1, it's just simply that force, which is 60 pounds, times that perpendicular distance, which is 1 times sine of 45 degrees, and that would turn out to be 42.4 pound-feet. Now that force, if we look at this diagram, would cause this unit to rotate in the counterclockwise direction. So I can either write it as a negative sign, because using, let's say, this as my coordinate system, if it's rotating counterclockwise, it would be considered negative. So I can do that, or I can say moment about point O due to force 1 is 42.4 pound-feet, and it's in the counterclockwise direction.